So welcome. As I mentioned on Friday, we would continue with the water supply design lecture today. We'll finish this lecture. Tomorrow we will start the election. We'll do a lecture on population predictions. So let's move forward with water supply design. As we discussed last week, we talked about the objectives of water treatment, talked about water demand, source water evaluation, and water quality. I'm going to talk briefly this morning about the evaluation of process options, just to give you some sense of how we put together the water treatment systems. And then we'll talk about plant sizing, layout, and location, really with regard to the Brighton plant that we've been considering. So let's really talk first about, how do we make these decisions about process? One of the major aspects that we'll consider is the water that is to be treated. Is it a surface water? Is it a groundwater? How hard is this water? Are there other contaminants that need to be treated? So for instance, if you're in the thumb area of Michigan, arsenic is a significant problem. So there you're looking at arsenic removal. We also need to look at the regulations. We'll put together a short pre-recorded lecture on the Safe Drinking Water Act. I'm going to do that as a pre-recorded lecture. You can watch that on your own time. It's not exactly the most exciting of material, so I thought it was best just to do it as a pre-recorded lecture. And then we also need to think about things like reduction of NOM for control of disinfection byproducts. That's reduction of naturally occurring organic matter, controlling disinfection byproducts. We also need to think about corrosion control. And then often what you'll find is that the process that is chosen will often depend on convention, what's acceptable in a particular region, what expertise does the consulting firm have? They're less likely to go out on a limb and actually design a process that they have little in-house experience on. So let's look at a number of options. The first is a surface water. Sorry, get this right. A surface water plant. And why is this doing this? So let's try the highlighter. I tried this before. It worked perfectly fine without being on Zoom. And doesn't seem to want to work for me right now. But here we have groundwater system. So we've got a groundwater system. So we're looking, for instance, at a system like Michigan State University. Now, MSU could have chosen a process like this. They did not. What they chose was a iron and manganese treatment system. And so here we have groundwater. The first thing we need to think about is what chemicals are we adding? So for softening, typically we're adding lime, soda ash. We have a rapid mix system, so we need to mix these chemicals very rapidly and forcefully. We want to make sure that we have good mixing. We then have a reaction basin where we're allowing the chemicals to react. And really what we're doing in the case of softening is a precipitation reaction. We then have settling, so we're allowing the solids to settle. We'll collect sludge. We then go into often a recarbonation system. Notice here we're adding CO2. So what we're doing is we're reducing the pH. We then treat through some sort of a filtration system. It may be a rapid sand filter. There's other types of filtration we can use. We can actually here, they show disinfection, so we're adding a disinfectant. Actually, often we will add phosphate or some form of phosphate as a corrosion inhibitor, and often we will add some form of fluoride as for the dental health is really. I'm going to go back to this slide, which I skipped. Here we have a surface water system. So now we're looking at a lake or a river. We initially have the addition of some sort of a chemical referred to as a coagulant. We then have rapid mixing. So we want to disperse that chemical into the water, so we need really good mixing. We then have very slow mixing where we're allowing these chemicals to react, basically form larger particles that will settle in the sedimentation basin. We then have some sort of a sand filter. And then finally, just as with the groundwater system, we have some sort of a corrosion inhibitor. So for instance, phosphate, orthophosphate, and often we will add fluoride for dental health. And then we'll disinfect. So we go in then to a storage, and then we distribute to the treatments, to the distribution system. When we look at direct filtration, the big difference here is we're looking at a much purer water supply. So for instance, Lake Superior, very clear, very little organic matter, very little nitrogen, phosphorus, so nutrient levels are low. And here what we can do, because we're not going to produce a significant amount of solids, what we actually do, we have the same sort of initial process here, okay, as we had with the other surface water system, the more the more turbid water supply. So for instance, Lake Huron, Lake Michigan, these are still relatively pristine water sources. However, they do have enough organic matter present, enough color, enough turbidity that we can't use a direct filtration system. So in this case, we're not producing a significant amount of solids, so we can go directly into filtration. So you notice there's no sedimentation. In some cases, there isn't even a flocculation basin. So in some cases, dotted line here, in some cases, you don't even have a flocculation basin. Basically, you're allowing these chemicals to react within the piping network. And then we go into this rapid sand filter. And again, we're going to have the same thing. We will have a corrosion inhibitor. And we typically will have fluoride addition. So, and then in terms of disinfectants, we'll talk much more about that later in the semester. But the most common are chlorine, hypochlorous acid, sodium hypochlorite, and I'm just going to write it down as chloramines. We'll talk much more about that later in the semester. So what I'm going to have you do, I'm going to try and do this as a breakout group again. Got some positive comments about the breakout group, so we'll see how this works. So what I'm going to have you do is we're going to go back and we're going to look at essentially the questions that I asked you on Friday that I didn't give you enough time for. We've got more time today. So what I'd like you to do is to work in your small groups. I've given you the Google link. I will add that again. But what I'd like you to do is meet in your small groups, introduce yourselves so that you get to know each other. And then I'm going to give you 15 minutes, so we should have more than enough time. I want you to think about how would you determine the flow rate for the Brighton water treatment plant. You can go back, look at the maps, think about what considerations we mentioned, what would be the service area, so determine your service area. How would you expect the flows to vary? Think both on a diurnal level and also think on a seasonal level. How do these vary over time? And how does that impact your plant? Then you can think about what policies could be implemented to reduce water withdrawals. So how can we conserve water? So what I'm going to do is let's go now into the breakout rooms. So we're going to, okay, we should be back. Should be all back. And thank you for participating in that. I'm going to ask if maybe someone from group 2, and I should be sharing group 2's suggestions and thoughts. Would someone from group 2 like to unmute themselves and talk a little bit about what your thoughts were?
So for the first question, to determine the average maximum daily and peak hourly flows, we thought that you would need to know like the population size and what kind of like manufacturing and industry would be there. And then like maybe if you had an estimated like water demand of that community or like communities around it, you might be able to figure out like what the peak hourly flow rate might be.
Excellent. Anyone want to add anything to that? Mute yourself and silence. One of the things that wasn't mentioned was the service area. So one of the things to think about is, what does your community look like? Are you just serving the city of Brighton? Would you be serving some of the surrounding townships? There's a number of townships, Genoa, Brighton Township. Do you serve those townships also? It was great mentioning manufacturing industry. Also, hospitals. Hospitals tend to use a significant amount of water. So that's another thing to think about in terms of water usage, and then also in terms of wastewater, because there's certain aspects of hospital wastewater that you really need to think about, and whether or not that needs to be pre-treated, which we'll talk about that later, but that really will play into all of your calculations, all of your decision making. Okay, if you can talk about how you expect the flows to vary, that'd be great. Someone again from group 2, I'll let you.
So for the flows to vary, we figured in the summer there'd be a higher water demand because of like pools and watering lawns and all that. And then we said that there would be higher flows like in the morning when everyone's getting ready, and then also during the day, like less water demand at night.
Typically very true. It's kind of, do you think COVID has affected these water flow patterns? Anyone?
I feel like it definitely has, because like during the day, people are home, less likely to be at work, like cooking more.
Plus, industries were operating at a much lower capacity.
Mm-hmm. I hadn't really thought about it until we're talking about it right now, but absolutely significant changes. I mean,
I think people are just washing their hands more and stuff too, even.
mm-hmm. Very true. And even I think initially, I don't know that people are still doing it, but the thought was that even if you like went to the grocery store, you should come home, change your clothes, take a shower, and wash your clothes. So some people were probably doing that more than, so maybe get more usage during the day. So my guess is, and it would be interesting when we have some of the guest lecturers from the utilities to actually, we could ask them whether or not they've seen some different patterns. I can't imagine that they wouldn't, given the changes in all of our lives since March. And then last question that I asked you was policies that could be implemented to reduce water withdrawals. I'm going to call on, since I've got group 2 up here, I'm going to call on group 2 again. I won't do that again, or we'll just rotate groups. But group 2, if maybe you can talk, and then others can chime in with their thoughts if they have anything else. So someone from group 2 again.
So our ideas for reducing water withdrawals was we could like limit the number of days a week that you can water your lawns, or offer like a tax break to industries that use less water, or even like requiring a withdrawal permit if you take like a large amount of water. Someone in our group said that in Michigan they have that.
And that's they absolutely, well, they do for groundwater. So for instance, with a well, if you, I think it's 70 gallons per minute. So if you extract more than 70 gallons per minute, you need a permit. Any other things, measures, policies that could be taken? Anybody want to add anything? I think group 5, you've got something. Group 3, you had some.
Yes, someone in our group said that you could implement more routine checks for leaking pipes or things like that in homes and industries and buildings.
Very true. I had been involved in a water study on campus back, actually now it's almost a decade ago. And one of the challenges that we had was trying to figure out what the leakage rate was on campus. They kept telling us that there was a report. Nobody could find the report. But checking for leakage and knowing what that leakage is and having data in a form that's readily available is really important. Group 3, you had talked about regulations for new houses. Kind of what were you thinking with that?
In terms of the leak policies and detecting leaks?
I'm not sure.
What you're asking?
It just says regulations for new houses, so I'm just wondering what you were thinking. What sort of regulations might we implement?
I don't think we talked. I don't remember talking about that.
Okay.
I'm sorry.
I mean, one of the things was group 5 mentioned mandating low flow faucets and toilets. You could actually regulate that for new homes so that at least all new homes would be equipped with low flow devices. Just kind of
could something else be for new homes? Like some buildings use hot water to heat and cool their buildings. I know usually it's a cyclical process, so they just keep the water. But even if you didn't have that process, would you be conserving water?
My really does tend to be tied, for instance, with a power plant. So MSU's power plant is actually a cogeneration plant. It was designed initially not to produce electricity, but actually to produce heat. After a number of buildings burned down, MSU decided that they needed to build their first power plant. So it wasn't electricity. So basically, the steam that's used for heating and cooling is really produced as part of the power plant. So I don't know of any building per se that as a single building that's done, but for instance, down in Lansing, a lot of the buildings are heated by steam heat, and that's the steam's produced by the power plant, the Rio power plant. And then MSU's buildings are heated and cooled with steam, and again, that's produced by the power plant.
Okay.
Group 7, you have something that nobody mentioned.
Do you mean informing residents?
Actually, the next, well, you could, and then the other one.
Oh, meterage limits?
Yeah. So simply installing meters reduces usage. It was interesting when I was on sabbatical in Christchurch, New Zealand, they don't have meters, and the water consumption during the summer there just goes through the roof. They, on average, they're consuming about 700 liters per person per day, which is almost twice what we're using in the US on average. And a lot of that is actually water in gardens. They don't have meters, and they've actually talked about putting in meters to try and limit water consumption. You can typically, it reduces water consumption by 40%. So that's another thing that can be done. So great. Well, thank you. We're going to talk about, some of you actually answered the opportunity cost. We'll go back to that. So thank you. Hopefully that was useful in terms of kind of working through and thinking, and I gave you more time, so hopefully that helped with the kind of thinking through some of these questions. So moving on, once we've determined the service area and we're starting to, we've made a decision about what the average flow rate, we've calculated the maximum daily, we've calculated our peak hourly flow rates. Now we need to move on and think about the plant sizing. So we've made a preliminary selection of a water treatment train. And now we want to start going through, and we'll look at, so we're going to start determining the sizing of the various units. And we need to do that because we need to know, does it fit within the site location? So maybe we've thought about where that plant could be. And then also we've got some idea of what the cost, at least the range in costs should be, so we can start to make those decisions. So we need to think about the number of units. We'll start thinking about the size of the units, and we will be doing this as part of the preliminary design process that we'll go through. We'll also need to think about, and we'll talk about this a little bit more, but what ancillary structures do we need? We'll identify some of those. One of the things you want to think about is if you need to expand the plant, do you have enough land to do that? So for instance, the East Lansing plant, that is off of Bertram Road, it was actually designed so that if the population increased as they anticipated that it would back in the 1970s when they first built the plant, they could actually build a mirror image plant. So there was enough land that they built the plant, and then they would build a mirror image of the plant on the existing land. The other thing you need to do is that when you're thinking of the layout is the access to both the transportation network, the power grid. How can you get power into this facility? And are there roads? Are the roads sufficiently accessible for the traffic? Is there an existing distribution network? So, for instance, maybe there are multiple wells, but there's no treatment. So, in fact, Brighton was doing this up to about a decade or so ago, where they did have wells. They had essential wells, but they were just distributing water out to the community, but it was untreated water. Williamston was doing the same thing. Actually, Michigan State was doing the same thing. There was no treatment plant. They just had wells that water went to a central storage, and from that central storage, it was distributed. And then the other thing is residual handling. So do we have the space and the facilities to manage the waste that we're producing? Typically, this is sludge from the production of, for instance, there's softening sludge. East Lansing has basically drying lagoons. So they pump that, or dewatering lagoons. So they pump that sludge out to these large lagoons. The water evaporates, and then when there's a sufficiently high solids content, they excavate the lagoons, and then they sell off that material as land amendment. So it's basically calcium carbonate that can be used to neutralize the acidity on plants. So when we're looking at number and size of units, important aspect, and I've added 3 exclamation marks for that, and I realized I just want to make sure that I'm, yes, okay. For a second, I thought I wasn't sharing the right screen. So you want to think about redundancy. The last thing you want to do is wake up in the morning, turn on the water faucet, and find out you didn't have water. It's bad enough I got up this morning, had internet, and all of a sudden the internet went out. Just debating what I was going to do. But you sure don't want that happening with water, okay? If you lose the ability to distribute water, you actually lose the pressure. You then issue boil water alerts because of the potential for bacteria to infiltrate into the system. So we want to make sure that we can produce water 24/7, 365 days a year, without interruption. You will have at least 2 of every unit. Units, pumps, tanks need to be taken down for servicing. You need to be able to supply water with 1 tank out of service. So for instance, in East Lansing, there's 2 treatment trains. So water comes in, okay, goes through a softening process. I'm not going to go into these details, but there's 2 identical treatment trains. And then that water combines here and goes to the filtration units. And there's multiple filtration units. So the way this operates is that in the city, well, it's East Lansing Meridian Township, can produce sufficient water with one treatment train out of service. And what they actually do is they alternate on an annual basis. They actually alternate taking one of these treatment trains down for maintenance, and then they process. So the entire flow, okay, their peak daily flow can be treated through one of those treatment trains. Now, if you have multiple systems, so if they were to build a multiple system out here, running out of space, then you'd have 3 treatment trains, and basically these 2 treatment trains could together produce or meet the peak daily demand. Okay, but East Lansing only has 2 treatment trains, so one treatment train has to meet the entire process. So question, is it still legal to do without any treatment? And the answer is yes, if it is a groundwater supply that is not under the influence of surface water. So basically, there isn't, these are deep wells, they're not affected by surface water, then yes, you actually don't, not only do you not need treatment, but you don't necessarily need disinfection, and you don't necessarily, and you don't need to actually monitor for disinfection residuals in the distribution system. If it is a groundwater under the influence of surface water, you do. Now, East Lansing, this is kind of a difference between, for instance, the Williamston system and the East Lansing system. Both of them use groundwater. MSU's system also uses groundwater. So they're all essentially using water from the same aquifer. The difference is that, and neither Williamston nor neither Williamston nor MSU are groundwater systems under the influence of surface water. East Lansing was. Now, they've changed this recently. And the reason was because they have these softening lagoons. They took the sludge, remember I mentioned this, and this gets pumped out into these dewatering lagoons. They also pumped the backwash water out there, and they recycled some of this water back into the plant. So basically, there's a significant amount of calcium carbonate in there that raises the pH, so they can do pH adjustment. Because of that, it was a groundwater system under the influence of surface water. Okay, so it's groundwater system under the influence of surface water. That means that all the surface water rules actually are applicable to that groundwater system. They have changed the system so that they no longer recycle water back into the plant. And by doing that, they are now just a groundwater system. So they're only the groundwater rules apply. So yes, it's still legal to distribute water without treatment if it's a groundwater system, not if it's a surface water system. Okay. In terms of ancillary units, we need an administration building, or at least space. Got to keep all these records. Somebody has to operate the plant. There are laboratory tests that need to be done on site. Some of it more complicated testing that is only perhaps annually done, or even in some cases every 3 years, like the lead and copper rule, that can be sent off-site. But there's a significant amount of routine analysis that must be done multiple times during a day. So you want at least a basic lab there. You need storage tanks for various chemicals. So this can be for chemicals. This could be for treated water. It could be, in some cases, untreated water. So for instance, with the new treatment plant that Genesee County built, they actually pump untreated water from Lake Huron to a storage tank on the outskirts of Flint. They have at least 3 days worth of water there. I think it may be longer, but it's at least 3 days. So they have untreated water in case, for instance, a pipeline breaks. And then they treat water on site and then distribute it to the area outside of the city of Flint. City of Flint is still purchasing water from the Great Lakes Water Authority after the whole Flint crisis, when they went back onto purchasing water. So the city of Flint is purchasing treated water from the Great Lakes Water Authority. The Genesee County outside of Flint had built a pipeline, just transmits untreated water. They treat the water and then distribute it there. We need roads. We need parking. We need space for residual treatment and storage. And we may need a mechanical building for pumping. Much of this varies. So for instance, with the Genesee County, you're going to have an intake, and Lake Huron, you're going to pump. So you're going to have a mechanical building to pump that water from Lake Huron all the way to, I think it's Flint Township. And then where it's stored, you're also going to then have a pump to pump from that storage into the plant. And then you attempt to design, you want to design your plant so that water flows through your plant by gravity. I'm going to switch to presentation mode for these. So what I'm kind of looking at your site location. I've highlighted here the city of Brighton. You can see here we've got these suburbs, or these surrounding areas. It's working now. Okay, so we have these subdivisions here. And the question here is, are we distributing water to these subdivisions, or are we only distributing water to the city of Brighton? So that's one of the first decisions. Are we distributing water on the east side of I-23? Okay, so this didn't quite work because my markings are still here, but these are Superfund sites. You don't want to put a treatment plant close to a Superfund site. We've got potential for contamination of your soils, potential contamination of your groundwater. So in the case of this situation, we would want to avoid these areas here because of the potential for contamination. Okay. This is the FEMA wetland. Oh, sorry, flooding. So this is our 100-year flood zone. You definitely don't want to put your treatment plant, either a water or a wastewater treatment plant, in your 100-year floodplain. Recognize that these maps sometimes have not been updated, so you need to be careful about the use of these. There may be areas that do flood that aren't shown in the flood zone, on the flood map. And then lastly, we want to look at wetlands. So this is from the Eagle wetland map. And you can see here there's a significant amount. This is Brighton. This is the main part of Brighton right in here. You see a significant amount of wetland. You issues there with foundations, soil characteristics for construction. So you want to think about, do you build there? So perhaps maybe if we're looking, maybe this is the area we're going to kind of key in on and think about that, maybe the area. Or perhaps we have enough area in here, depending on the size of the plant and how we're treating the residuals. So consider that. Okay. The next thing we want to talk about, it's really the last thing we'll talk about today, are opportunity costs. So, and some of you obviously have talked about that in other courses, so you actually answered that question, but we'll just breakout groups to try and to think about that. So we'll use this first example here. You really wanted it's a nice, still warm, you want this nice drink, you go out and you buy a $7 strawberry smoothie. It's an awesome smoothie. Now, we can think about, what are the trade-offs? What could you have done with that $7? Perhaps you could have bought a kiwi smoothie, or you could have gone to an early afternoon movie. You could have bought gas to put in your car. You could have bought flowers. Or maybe you could think about, okay, I buy smoothies pretty often. What can I do if I didn't buy smoothies on a regular basis and I instead save that money? Or maybe if I save up enough money, forego 2 or 3 smoothies, I can go out to a restaurant. Or if I don't buy them for a much longer period of time, I can buy that violin that I really wanted. Or I can go on a vacation. Or I can buy the bicycle. So the opportunity costs are the alternate use of the same resource. So think about this, okay? You've got an exam the next day. And instead, you decide you're going to go spend 3 hours and $20 on a movie, going to a movie the night before the exam. So what's the opportunity cost? Anybody want to answer that? So you've got an exam, let's say tomorrow. And tonight, instead of studying, you decide you're going to go spend 3-4 hours and $20 at the movies. What's the opportunity cost? Missing out on the study time, great. Not doing well on the exam. Not having the $20, something else, potentially losing sleep. Yeah. And then perhaps losing sleep and sleeping through the exam at 8 o'clock the next morning. Okay, so those are those are opportunity costs for that. Okay. Let's say you've got a job, you've graduated, you've got a job, and you can take the train to work, or you can drive to work. If you take the train, it takes you 70 minutes to get to work. Same thing, 70 minutes to go home. If you drive, it only takes you 40 minutes. So what's the opportunity cost there? You've got this job, you can either take the train, takes you 70 minutes each way on the train, or you can drive and it takes you 40 minutes. So is there an opportunity cost? So via the train, losing time? Absolutely. If you drive a car, you run the risk of running into traffic and being late. Exactly. You can wake up later, so you get more sleep if you're driving. Saving money from taking the train and not buying gas. So we've more family time. So these are the things we want to think about. Okay, being able to do productive things on the train. So if you're driving, you've got to focus on that on the road. But if you're in a car, in a train, then absolutely you could potentially do more productive things on the train. Ignoring opportunity costs undervalues water, and it leads to failures in investments, and it causes misallocation of resources. So we want to make sure that we're achieving efficient water usage. So we want to recognize these opportunity costs. So I'm going to ask you, I'm going to put you back into breakout groups. I'm not quite sure whether Zoom will put you in the same breakout groups or not, but you've got the link. That won't change. I'm going to set this up for about 10 minutes. So what I'd like you to do is think about this. You can think about this again in terms of Brighton. Assume that Brighton is not treating or distributing water. Some of you figured that they were, and they are, but assume that they're not. Okay. What would be the opportunity costs for creating a community water supply? Okay, I think we should all be back. Yes, okay. So let's process and think about what were some of the items that you mentioned. I'm going to call on group 4. Could somebody from group 4 talk about what were some of the items that you identified?
Well, we were thinking about like location, so it could be used. So if you were to build a water treatment plant, then you wouldn't be able to use that location for some other kind of development, like housing or really anything, roads, and other stuff like that.
Good, exactly. Okay. Anything else? Got a few of them.
Also, like depending on if you were to use groundwater or surface water for the treatment plant, there would be just differences in like how to treat it and stuff.
Differences in treatment, and that affects differences in cost. So that cost could, depending on which one you choose, that there's an opportunity cost there. Cost could be used somewhere else. What else?
Right. We also said that the money
Absolutely. I don't want him roaming around next to you when I'm not
Do
here.
you care if one of my friends comes by? She wants to see the dog.
No, absolutely
Okay.
not. Just make sure he's on a leash, please.
Somebody
I will. Do you want to take about
that's
last?
talking right now, can you just put yourself on mute? So, sorry. Okay,
That's it.
back to group 4.
We also said that money could be used for some other kind of public service, like schools or roads or bridges, that kind of stuff.
Excellent. You actually initially you changed it. You had increased taxes, and then you've had increased cost.
Yeah, I didn't. I felt cost was a better all around thing to use.
And I'm going to kind of put this on a personal household level. So perhaps if there's increased taxes or an increased cost, okay, that is an opportunity cost. I think, so kind of scroll through these. Group 2, somebody from group 2. You had at least one other item that group 4 didn't mention.
We had sorry.
No, you go.
Okay, so we had costs for transportation. Like if you're servicing areas outside, just outside of the Brighton area, how you had on the map, or maybe areas farther from the pump station, then cost of transportation and the labor for the transportation.
Labor, okay. And then you had one other thing, the last item that you mentioned.
We talked about how like they have an increase.
I'm not sure whether it's my internet that or yours. I just lost you.
Oh, okay. We talked about how you had an increased water usage, but there was like a drawback with higher energy usage.
Okay. Potential increase in water usage, okay, and then increase in energy consumption. Anybody else want to add anything to this?
So something that wasn't talked about, I don't think, was so like location. You could, depending on how like aesthetic the water treatment facility is, it could be lowering home values, or it could upset people if it's a water treatment facility is right next to their homes or the residential areas.
Okay. Land values, okay. Also safety. The East Lansing plant, which when it was built was on the outskirts of East Lansing, and there were no homes surrounding it. And they used chlorine gas for disinfection. But as development happened around that area, you've got more and more homes. So basically what happened was that they were required to stop using chlorine gas just because of the hazards of a chlorine leak. And they now use liquid chlorine. So they use sodium hypochlorite for disinfection. It's more costly. It adds more dissolved solids to the water than chlorine. There was a trade-off in that, but the decision was made to switch because of safety. So you've got that aspect in terms of the homes. Anything else we can think of? You get a few others. One is if we remain on private wells and we're pumping less than 70 gallons per minute, we don't need a permit. So basically, if you think of all these homes, they're all pumping And they have, as long as they're pumping less than 70 gallons per minute, they don't need a permit, there's no regulations, and we have the potential for over pumping or mining of water. Significant reduction in either the water table or the pressure. You reduce the amount of water, and then you can actually get subsidence. So that's an issue. If we're all in private wells, we may have some homes with household treatment. So they have a household softening unit. There's a cost to that. They may be spending more money on home treatment, or maybe they're spending less. So there's that opportunity cost for that. There's capital costs, there's operating and maintenance costs for that home water system. There's the potential, actually, if our wells are too close to the septic system, we may need disinfection. And if people get sick, because they don't have disinfection, there's the potential for medical bills. So again, this is if the well is too close to the septic system, we have the potential for contamination. We either need to disinfect, or if we don't disinfect, we have the potential for people getting sick, coming down with waterborne diseases, and the medical bills associated with dealing with those. So those are just some of the opportunity costs that we can think about for a water treatment system. We need to think about those, and we'll talk later in this semester. I have an alumni, Danielle Yoon, who's going to come in and talk about financing of water and wastewater systems. It's a critical aspect of the process of designing, constructing a new system, and we often ignore that. So it's important to think about, so that we will talk about that later in the semester. Just in terms of wrapping up here, from this lecture and from chapter 1, you should be able to list and describe the factors that influence water demand. You should be able to discuss opportunity costs. I'll talk about, you should be able to at least basically compare surface and groundwaters and start thinking about what are the different types of treatment that you would need for those. And then you should be able to discuss the factors that influence plant sizing, layout, location, and think about opportunity costs. So we'll end there. We've got a few minutes. If you have any questions, feel free to write those in the chat if you have questions. The first homework is open, and make sure you start working through that. If you have any questions, please let me know. And we'll end here then. And we will continue talk about population predictions on tomorrow morning. And thank you for participating, and have a great day.